This message is for Travis in my Math 130 class. He had a question on inverse functions. In this problem, g of x is equal to 3x plus 4 and h is equal to these 5 points here, 1, 2, 3, 4, 5. It was a three-part question. First, they asked you to find g inverse. Then they asked you to find g inverse composite g at -1. And then they asked you to find h inverse 0. So I'm going to start off with part C because C is probably the quickest and the fastest one to do. So inverse means when you switch, if this is h, then h inverse will be switching the x's and y's. So here, if h is given here, then h inverse is going to be switching these points. It's going to be 2, -1. So your x value becomes your y value becomes your x value. So 2, -1, 9, 0, 0, 1, 8, 2, and -3, 9. So h inverse is when you occurs when you switch the x's and y's. So in the problem where it says find h inverse 0, so if the input is 0 for h inverse, then what is the output? So if the input is 0, so the input here is 0, then the output would be 1. So the answer to this is 1. So again, when they're asking you for h inverse 0, you could think of this as the input 0. So here's the input. The input is always the first value. So if the input is 0, then the output is 1. So you could do this by rewriting the h into h inverse and then finding out what the input is and hence the output. All right, the other part, I'm going to do part A here, find g inverse. So here's a function g, and they ask you to find the inverse of this. Well, the inverse of this, there are 3 steps. So here I have a person walking up 3 steps. So you want to follow these 3 steps. The first thing you want to do is you want to switch the x's and y's. So here, if you have g of x is equal to 3x plus 4, so when you have g of x is equal to 3x plus 4, so pretend this is like a y is equal to 3x plus 4. So the first thing you do is you switch the x's and y's. So y equals 3x plus 4, so I'm going to switch that. So that's going to become x is equal to 3y plus 4. So first, step 1 is switching the x's and y's. So this y becomes an x, 3x plus 4 becomes a 3y plus 4. The second step is to solve for y. So here is my y. I'm going to solve for it. So I want y to be sitting by itself. I'm going to subtract 4 on both sides. X minus 4 is equal to 3y. And then I'm going to divide everything by 3. So I have x minus 4 all over 3 is equal to y. And then the last step is this is your inverse. So this y equals to x minus 4 all over 3. This is the inverse. So if this is g, then g inverse is going to be that what you just wrote up there, x minus 4 all over 3. Okay? And then part B here, the last but not least part, it asks you to find composite function. So at this point, I'm assuming you know what composite function is. So g inverse composite g. So that is equivalent to g inverse. And then the inside function is going to be g -1. So with composite function, the first thing you do is you do the inner parentheses first. So g -1. So if you plug -1 into g, what do you get? Well, this is your g function. If you plug -1 in here, so if I plug in g of -1, I end up getting 3 times -1 plus 4, and that will give me -3 plus 4, which is equal to 1. So g -1 will give me 1. So here, this becomes a 1. So now, in other words, I have g inverse 1. So now we plug in 1 into our g inverse. What's our g inverse, this one? Plug 1 into here and see what you get. So if you plug 1 in here, you get 1 minus 4 all over 3, which gives you -3 over 3, which equals to -1. So that's what g inverse composite g at -1 equals to -1. Now, I want to point something out to you. Notice that I did this. It took me about a minute or 2 minutes to do this problem. The shortcut is that the property of an inverse function is that when you take the composite function of an inverse and of the function, you will always get the same value that you started off with. So notice when you plug in -1 in here, notice the answer is -1. So I'm going to write this here. The shortcut property is this, that by definition, if you have, so I'm going to just change it in general, f inverse composite f of any input, the answer will just be that input. So that was a 7, you get a 7. Was 8, you get 8. -1, you get a 1. That's true if this was reversed. If I had f composite f inverse at x, the answer is just x. Right? And that's why here, g inverse composite g at -1 is just equal to -1. So the shortcut is just to say that, but you can show it or prove it to yourself by doing that work. And therefore, it also checks to make sure that this really is the inverse of g, and you should get back the original input of -1.